Today let us study about some identities involving cubic polynomials. They are polynomials whose maximum degree is 3. The degree cannot go more than 3. Now look at the first identity. We add two numbers and then cube it, and this is how we expand it. Now look at the second one, the second identity. What change do you see here? What was plus here, the positive b has become the negative b. Then where all will you see the changes? Wherever your b has an odd exponent 1, 3, 5, in all those places you will see a negative sign. Wherever it is even, b raised to 0, by the way, b raised to 0 is just 1. It is here, you just don't see it. Here it is b raised to 0. So wherever your b has an even exponent, you will see a positive sign here. That is the difference between them. What we have done here, as with any other identity, what we have done here is that we have equated terms on one side and factors on the other. What are terms? Terms are those expressions which are separated by a plus sign or a minus sign. What are factors? Factors are those expressions which are separated by a multiplication sign. You don't see the multiplication sign, but it is there. So that is what the identities are all about. So here you have your factors, here you have your terms. Now look at the terms. You have 4 terms. Now we can write this same formula in a different way. Now look at this. I have rewritten both the identities in this way. Where do you see the change? There is no change in the factor part, but instead of 4 terms, I have gathered these last 2 terms and written it like this. And why is that? What difference does it make from 4 terms to 3 terms? That is what we are going to discuss first. Now here you have 2 forms of the same identity. For the same LH we have 2 different forms. But what is different? Until this point it is same. But this term is what makes all the difference. So whenever you see questions like this, dealing with fractions or dealing with decimal numbers, go for the second part, the second form. Why is that? Because of this AB term. Just look at this. Multiply these two there. See, you will just get a 2. Similarly, what can you express this 9.9 as? It is 10 minus 0.1, right? Multiply it, there you see 1. So this term makes calculation easier when it is a fraction or a decimal. So use the second one. We will use it and find the answer. 9.9 is just 10 minus 0.1. How do you cube it? First cube 1, which is just 1, 3 zeros. Here 1 decimal point, multiplying it 3 times would mean 3 decimal points. Now you see how far away I have written the third term, because I often see students getting confused what comes where. They will multiply this 0.1 cube into 3. I don't know how that does, but when they write it close enough, they just lose track of what is happening and end up multiplying this and this. No, this is separate term here. So that is why I have written it separately, and you also, when you write it, please write it a bit far away so that you don't get confused. This is one separate term, and this one we did already. Now in the brackets again, don't do the answer. A plus B, A plus B, just your question. Carry out your question and write it here, and then when you do the calculations, this will be your answer. Now what do we do? Cube of the first term, which is x cube. Cube of the second term, remember, cube both the numerator and the denominator, 8 and x cube. What about the third term? You know why we chose this particular form? Because of this AB. This whole thing is going to get cancelled and you are going to be left with just a 6. There. If you want, and this A plus B is just the question here. Carry out the question, just write the question as it is. This is your answer. If you want to open it again, you can open and write like this. Now we come to this question where you see a fraction, but we will not use the second form. We will use the first form. Why is that? Look at the fractions here carefully. It is of the form A plus B and a minus b. And then why are we using the first form here? Let us find out. This is the question we just now did, but here I have added another term. Now what does it look like? If you take x is equal to a and b is equal to 2 by x, what do you see? It is of the form a plus b the whole cube and a minus b the whole cube. Then what do you see when you expand it? What do you notice here? You have same terms but different signs. Now when you add it, what happens? And when you subtract it, what happens? When you add it, what happens is whatever has opposite signs gets cancelled. B cube minus b cube, this and this gets cancelled, and what remains? Only the ones with the same sign. That is an a cube here and a 3ab square here. When you subtract, then what happens? Then when you write a minus sign, remember to change each and every sign. That is how the associative property works. You can't just put one minus here. Each and every one change it. Every plus turns to minus, every minus turns to plus. Then what happens? Then what is left? Whatever used to be different sign, that is what is left. Now a cube and minus a cube will get cancelled, and what will be left? These two. So when you open the brackets, you will get 2b cube and 6a square b. Now our question was plus. So what do we do? When you add it, what all will get cancelled? All of this will get cancelled, and you will get double of which two terms? This term and this term. You just get the double of these two terms. Remember, it is a standard formula. Whenever you see questions like this, not only in the cubic expressions, in the quadratic also, raised to 2 also, you have to follow the same method. See if it is plus or minus. If it is plus, these two will be what you are getting. If it is minus, then the other way. Now these are two similar questions. You can do it yourself. It is a plus b the whole cube minus a minus b the whole cube. What is the a here? A is x by 2 and b is y by 3. So you can do it the same way. All the equal but opposite terms will get cancelled, and what will you be left with? This is a minus sign. That means any y cube and y terms will be left. Y cube term will look like this, and the y term will have the square of this, right? Then the square of the first term and the y term will be left. Here, look at the question, it is slightly different. The minus part comes here. Here the minus part comes here. Here the minus part here comes here. So the whole answer will have a minus. Again, continue the same way. This is A, this is B. What will be left? All the ones with equal terms, different signs will get cancelled. Again, you will be left only with the y cube and the y terms. You can do it yourself and check out. Now look at this question. This is a step problem. Now where do we start? We have x raised to 4 plus 1 by x raised to 4. Can you think of anything that connects it to x cube plus 1 by x cube? Absolutely not. It is completely different. You will not find any identity connecting them. But we have to start somewhere, right? Look at this. X raised to 2, x raised to 4. 1 by x square, this. So that will be a good place to start. We will square it and see where it takes us. Now taking and squaring this term, what do you get? Square of the first term, square of the second term. What about the middle term? What is the best thing about terms which look like this? When you are dealing with fractions, they get cancelled. See? And then you are left with something neat. It is just a 2. So what do we do? Substitute the values. What is the only value you know? It is just 194. Substitute it. You will get 196. That is what? The square of this whole thing is 196. So you have both the negative and the positive roots, but I am just taking the positive root here. Is 14. The square root of this is 14. So there you have got one answer. From there, how do you proceed? there is a way to connect these two, right? X square is this. So let us try that also. Again, take two numbers and square it. Square of the first term, square of the second term. What about the middle term? Both of this will get cancelled. It is again the 2ab term. You have an x and a 1 by x. They both get cancelled. You are left with something very neat, which is just a 2. But then what is this? We just found out it to be 14, and add a 2 to it, you get 16, but it is the square of this number. Take the square root, you have this. There you have got this also. Now what is left? The last one. That is easy, right? That's what we are studying now. We studied two forms of the same equation, a plus b the whole cube. We studied two forms. Which one do we use? Whenever you see such questions like step problems, look out for the one which has the AB term. Now substituting the values, we found that this one is 4. That is what we found out, right? So substitute it here, you get a 4 cube, and this is our question. I have written it far away so that you know that this is separate. Don't confuse with the two. Now what is your answer? Now in the last question, what did we do? We started from 4 and then found out all the lower degrees, 3, 2, 1. But here we are going the other way. We are starting from the lower degree and then going to find all of that. How do you even start with x and go straight to x raised to 4? There is no way. Let us take baby steps. First this and then the others. Let us start now. Now let us do the basics first. Let us just square it. When you square it, what happens? The square of the first term, square of the second term, what happens to the middle term? Now both of this gets cancelled and you get a very neat, a very beautiful 2. But what is x plus 1 by x? This whole thing is 3. But you have to square it, which means it becomes 9. Then take the minus 2 to this side, you get this whole thing is 7. That is your first question answered. Now if you double it, you cannot get 3. There is no way from this you are going to get 3. If you double it, what happens? You get x raised to 4. You get this term, you will not get 3. So let us go to that part of the question first. Let us square it. Square of the first term, square of the second term, as usual. The middle part, both of this get cancelled, you get a 2. But then what did you find this out to be? This was 7. Square it, you get a 49. Then when minus 2 comes here, you get 47. So that is this question answered. Now comes the important question. How do we get an x cube? If you keep on squaring it, from 1, from x you will get x square, then x raised to 4. If you square it again, what are you going to get? You are just going to get an x raised to 8. But there is no way you will get to an x raised to 3. Then how do we do it? What about you cube this? Maybe that will help you. Try cubing this. There we are down to our basic identity that we started with. Cube of the first term, cube of the second term, the 3ab term, where both of them gets cancelled and you are left with a 3. And what is x plus 1 by x? That is already given. It is 3. So 3 cube is what? It is 27. And I have written this far away so that you know it is just one term. There are just 3 terms in this form. So 3 into 3 is 9. Then you bring it, this plus you bring to this side, and your answer is 18. Now I think we are getting too comfortable with this question where we can cancel this. Next we will see a question where you cannot cancel but still use the same formula, use the same form of the equation, because that will help you always with the step problems. Now look at this question. Here there is nothing to cancel out. How will you do it? These two quantities are given and this is asked. Can you think of any identity which will combine all the 3 of them? Nothing that we have learnt so far. So why don't we take 2 at a time? Why don't we just connect these 2 and find what the AB is? We will first do that. Now can you think of any identity which connects both of this? Square this, and all you need is a plus 2ab. And when you substitute, what happens? It is 10 square is 100, and this is given as 58, and that will give you your AB. What will your AB be? It will be 100 minus 58, and then a 2 here. This comes down, so your answer will be what? 21. There you have got your AB. Now that will help you to solve this, right? Now there, a plus b the whole cube is this. What all do you know? A plus b is given. So wherever you see a plus b, substitute 10. What did we find out using this information? We found out that AB is 21. Substitute that. This is whole one term. The whole thing, take it over here. Then you get minus. This whole thing is 630. Take it here, minus, and this is your answer. Now let us do one more question. We will wind up our class with that. What do you see here? You see x plus y and x minus y. What does that mean? When you add it or you subtract it, lot of terms are going to get cancelled. So open the whole thing. This is how it looks. X plus y cube is this, and x minus y cube is this. So what are you doing? You are subtracting. When you subtract, each and every term changes. Whatever is plus here turns minus, whatever is minus here turns plus. So what all gets cancelled? These terms are what gets cancelled. What are the only two terms that remain? The y cube term and these two, the y term, the odd exponents of y is what remains, but then it is added 2 times. Y cube plus y cube is 2. So just write a 2 here and write down these two terms as it is. Now opening the brackets, you get 2y cube plus 6x square y. But that is not our question. You have another one term added to this. So we have found out what this much is. The answer of this much is what you have here. But then to that you have another term. Write down that term as it is, and here substitute the answer. What do you see? 6x square y minus 6 here, x square y. Same term gets cancelled, and you are left with what? You are left with an 8y cube. Now that's all for today. Till I meet you next time, you take care. Assalamu alaikum.